طيب شباب. Bismillah. So let us continue where we stopped last time. Last time we introduced the second law of thermodynamics, and we said the first law is not enough to determine the direction of a process or whether this process is possible or impossible. And also we need a law that can tell us the best theoretical performance of systems or processes. And then we said we talked about what is the second law, and we talked about three different statements. We talked about the Clausius statement, the Kelvin-Planck statement, and then we started talking about the entropy statement. So we defined what is entropy, and today, inshallah, Shabab, we'll talk about the statement related to entropy. We said entropy is, you can think of it as an energy or heat that is generated by the molecules due to these irreversibility sources. We talked about maybe friction, we talked about heat transfer, which makes these irreversibilities will cause the path to deviate from the ideal path. Okay? So, and then the entropy will be generated. So the statement for entropy generation is the following. This is the third statement of the second law, which is the entropy statement, which says that it is impossible for any system to operate in a way that entropy is destroyed. ايش يعني الكلام هذا؟ يعني once I generate entropy, once this energy or heat is generated and it's lost, is useless, okay, you cannot destroy it, or you cannot take it back, or you cannot reverse this process. Okay, so once you generate entropy, you cannot destroy this entropy. This is what the statement says. Okay, and this is experimentally proven in the past. في أي سؤال على الستيتمنت؟ في أي سؤال على الستيتمنت؟ طيب, we'll continue talking today about now we talked about the irreversibility. Okay, we said these sources of irreversibility causes the path to deviate from the ideal path, and so if there is irreversibility, we call this a reversible process. If there is no irreversibility, we call it reversible process. So let's talk about the irreversible versus reversible process. Before going, let me give you just more examples of the irreversibility sources. We talked about the heat transfer, which is one of the most important irreversibility sources. Okay, whenever there is heat transfer, there is entropy generation. Okay, so whenever there is heat transfer, there is entropy generation. Other examples include if you have unrestrained expansion, maybe we have talked about this as well. If you have unrestrained expansion of a gas or liquid, let's say you have a pressurized tank, you open this tank and the gas just escapes and you cannot bring it back. Okay, this is a source of irreversibility. This causes entropy generation. Other example is chemical reactions. So if you have a chemical reaction that you are not controlling, all right, this is also a source of irreversibility that will cause entropy generation. Let's say you have mixing of matter. Let's say you have salt or sugar. You mix it and you dissolve it in water. Once you do this, you cannot reverse it. Alas, the salt and the molecules are homogeneous and are mixed with the water molecules, and you cannot take it back. This is you generated entropy. Also friction, ya shabab. We talked about, maybe last time we talked about friction as well. Let's say in the piston cylinder device, you have piston moving and you have friction. You are generating heat because of this friction. This is a source of reversibility. You generate entropy in this case as well. Okay, so these are some of the examples that causes some of examples for irreversibilities that will result in entropy generation. Okay, so in reality يا شباب, all actual processes are actual processes. Okay, يعني in nature any process is actual process which includes all or some of the above irreversibility. In this case يا شباب, if I have a process that includes irreversibility sources, I call this irreversible process. Irreversible process. However, if I have a process that doesn't have any of the irreversibilities, or you can neglect these irreversibilities, you can approximate or neglect these irreversibilities, these are called ideal processes. Okay, so ideal processes are processes where the irreversibility sources are ignored or neglected. In this case يا شباب, we call it a reversible process. A reversible process. Who can give me an example for reversible process that we can approximate it as reversible? Hi Shabab, and we talked about this a lot actually. من يقدر يعطيني example for reversible process؟ يعني a process that happens and I can reverse it. ما شاء الله. I need your cooperation. جاوبون ولا أعطيكم كوز؟ ها شباب. تسمعوني أنتم ولا راقدين؟
لا نسمعك.
من اللي رفع يده؟ مصطفى مدري.
Doctor, how would you change the properties of a system without applying energy? I assume if there is energy applied, there will be entropy.
عيد سؤالك.
How can you change the properties of a system without applying energy or work?
قصدك without transferring energy.
Yes.
أنت جاوب. Can you do that?
I think no. I think there would be always entropy due to the applied of work or energy.
شوف أنت لازم ترجع للكونسبت. أنا وش قلت لك الحين؟ قلت ممكن في processes you can consider reversible, معناته you don't generate much entropy. أنا قلت لك برضو إنه all processes are actual processes. يعني كل البروسيسز في الحياة غالبا فيها entropy generation. بس في بعضها you generate very small entropy, so you can kind of ignore or approximate as reversible. Okay, so some of the process وش ممكن تفكرون في process يعني شيء يصير وتقدر ترجعه للأوريجينال ستيت. يعني تبدأ بستيت وتتغير الستيت بعدين ترجع للأوريجينال ستيت. زي ايش؟
Maybe the oscillated system.
مطاط مثلا أو البالون.
أيوة. أوكي. غيره. الإيفابريشن يا شباب، صح ولا لا؟ When I evaporate liquid, let's say in a piston cylinder, okay, I evaporate. Let's go back here. So let's say I have a piston cylinder. I have liquid. I transfer heat to it. I change it to vapor. Okay, so when I do heating, I get vapor. If I cool it, which I see, I go back to liquid. Is this reversible or not?
Yes, it is.
This is reversible. Okay.
But
So yes.
you applied heat here. We said heat is always irreversible.
ممتاز. ممتاز. Very good point. الحين الهيت where did it take place?
Outside our system,
Exactly.
so we don't consider it.
So it happened outside our system. معناته ايش؟ في شيء يا شباب مهم لازم تعرفونه. في شيء اسمه internally reversible process. So this process is internally reversible and externally irreversible. لأنه الheat transfer happened through the surrounding and across the boundary. It did not يعني generate within the system itself. Okay. فالبروسيس هذه it is internally reversible لكن externally irreversible. Okay. And this is important concept to understand here. Is that clear? Any questions here? فطبعا ممكن احنا شوي يعني عدينا نقطة اللي كنت بذكرها انه reversibility can happen within the system only, can happen within the surrounding only, and can happen within both the system and its surrounding. All right. If it's happened within the surrounding only and the system is reversible, this is we call it internally reversible process. Internally reversible process is a process where the system itself is reversible, like the example I gave you here. Okay, so this is internally reversible, externally irreversible process. Any questions here? Any questions? واضح ايش يعني reversible and irreversible? Reversible يعني there is no irreversibilities within the system, and irreversible means there is irreversibilities within the system. Any questions? طيب, we would like to talk about the performance now of cycles. Okay, we want to talk about the performance of cycles. But before that, يا شباب, let's relate the Kelvin-Planck statement mathematically to the concept of irreversibility. Okay, إذا تذكرون يا شباب في Kelvin-Planck statement, what did we say? So this is the Kelvin-Planck statement. قلنا إنه it is impossible, يعني مستحيل إنه a system that's going through a thermodynamic cycle that it delivers net amount of energy by work to its surrounding while receiving energy by heat from a single thermal reservoir. يعني لو عندي system زي كذا going through the cycle is in contact with only one thermal reservoir, it can never generate positive work. معناته الورك هنا mathematically وش بيكون؟ بيكون either 0 or less than 0. Okay, so the work of the cycle here is either 0 or less than 0. طيب يا شباب, based on the reversibility concept and irreversibility, يعني reversible versus irreversible process, for a single reservoir for this thermodynamic cycle, what does 0 refer to and what does less than 0 refer to يا شباب؟ يعني متى يكون عندي الwork of the cycle 0, متى يكون عندي الwork of the cycle less than 0؟ مش تتوقعون؟ الحين السكند لو يقول لي انت مستحيل تسوي positive work اذا انت only one single reservoir. فمعناته عندي الورك يا زيرو يا less than زيرو. متى يكون عندي زيرو؟ متى يكون عندي less than زيرو؟ وش تتوقعون؟ And related to the reversibility and irreversibility.
If it is reversible, it would be 0.
معناته if it is reversible, this is actually correct. So if it is a reversible process, that means if there is no internal irreversibilities, the work of the cycle will be 0. Okay? If there is the internal irreversibilities, we will see that the work of the cycle is actually less than 0, so it is irreversible cycle. Okay, so we can go back here, and this is what we have here. So the Kelvin-Planck statement, the mathematical form, is that work of the cycle is less than or equal to 0. It's going to be equal to 0 if there is no internal irreversibilities. If it's going to be less than 0 if there is internal irreversibility. And this is just by combining the Kelvin-Planck statement with the concept of irreversibility. And I think the book has the proof that it's proving this word, this connection, this correlation. Okay? Any questions? Any questions? طيب, let's talk now about the performance of thermodynamic cycles يا شباب. The performance of thermodynamic cycles. احنا ذكرنا لكم يا شباب قبل, if you remember, we talked about the 3 different cycles. We talked about a power cycle, we talked about a refrigeration cycle, and we talked about a heat pump cycle. قلنا في الباور cycle the objective is to generate power from a heat source. I have a heat input and I'm generating power. The refrigeration cycle, I have power input and my objective is to cool a certain body or I have a cold side that I'm gonna cool down. And the heat pump cycle, the objective for it is to use power input to heat something, heat a body or heat a certain site. Okay, so these are the 3 different thermodynamic cycles. So let's talk about the performance يا شباب of these thermodynamic cycles. So I have what I call a power cycle and I have the thermal efficiency يا شباب. Thermal efficiency. As a general rule, قاعدة عامة, if I want to evaluate the performance of anything حتى لو مثلا موضوع جديد أو application جديد I'm trying to explore, if I want to evaluate the performance, I usually take the output and I divide it by the input. Okay, so I take the output and divide it by the input. In this case يا شباب, what is the desired output for the power cycle? The desired output here is basically the work output that you need, or the power that you need to generate. The work you are generating, this is your desired output. And your input in this case is the hot side or the hot source. In this case, I call it QH. If you notice here, Shabab, I'm generating power. Why? Because I'm in contact with 2 thermal reservoirs. Remember, in second law says you cannot generate work unless you have at least two thermal reservoirs in contact with the system going through a thermodynamic cycle. So I have a hot reservoir, I'm taking hot heat from the hot side, and I'm dissipating heat to the cold side. Okay? In this way, I can generate positive work. So I can rewrite it as work of the cycle divided by the input, which is Q hot. And I know that the work of the cycle equals the heat of the cycle, which is basically the difference between the hot side and the cold side heat transfer. So I can rewrite work of the cycle as Q hot minus Q cold. Then I can divide this by each term, and then I get 1 minus Q cold by Q hot. Q cold by Q hot. And this gives me the thermal efficiency of a power cycle. Okay? This is supposed to be the actual thermal efficiency. Okay, and the heat transfer, I can measure this heat transfer I'm taking, and I'm rejecting some heat to the cold reservoir, and also I can measure the heat transfer. So 1 minus Q cold over Q hot gives me the actual efficiency of the power cycle. طيب السؤال الحين يا شباب, what conclusions can I draw? يعني وش ال expectations or conclusions that I can have by looking at this equation and also comparing it with the information from the second law, the limitation that the second law gives me. شباب, يعني أعطيكم مثال. Let's talk about the maximum performance. كم الماكسيمم performance؟ هل تتوقعون الماكسيمم performance can reach 100%؟
No.
متى هذا يكون 100%؟
when H is infinity.
أو Q, لا أنت مو H infinity, when the cold Q cold is 0, صح؟
Yes.
لكن السكند لو يقول لك مستحيل يكون 0 لأنه you have to have a cold reservoir. Q cold 0 means there is no cold reservoir. I'm not dissipating heat to any second reservoir. وهذا الشيء حسب the second law is impossible. فبالتالي from this we conclude that from the second law and from this equation we conclude that the maximum performance theoretically is always less than 100%. Okay, so the maximum performance must be less than 100%. يعني مهما حاولت, if you want to generate positive work, مهما حاولت تقلل Q cold, you have to have Q cold. لأنه if you don't have Q cold, you will not have power out. فبالتالي even though you try to increase QH and reduce Q cold, your maximum performance will always be less than 100%. واضحة هذه؟ Is this clear?
اي واضح.
طيب, what is the other conclusion? Okay. Let's think about the actual versus ideal cycle. تتوقعون أو reversible versus irreversible cycle, وش البرفورمانس؟ هل بيكون أعلى للreversible أو irreversible؟ ها؟
Again, Doctor, please.
The performance, is it higher for reversible cycle or for irreversible cycle?
Irreversible.
For إيش؟
Or irreversible.
Reversible will have higher performance?
No, the irreversible will have a higher performance.
Okay, so the other conclusion is that the performance of a reversible cycle is always less than the performance of a reversible cycle. Okay, so the performance of a reversible cycle, يعني لو عندي actual cycle فيها irreversibilities, the performance is gonna be always less than the performance of a reversible cycle where there is no internal reversibility. Okay, so this is very important. And the last conclusion يا شباب is that تخيلوا ان عندي two cycles, each one has different objective. خلينا نقول السايكل الاول is objective to for example run a pump. The other one is to run a turbine, for example. It has two separate objectives. Like both of these cycles are in contact with the same thermal reservoirs. For the same thermal reservoirs. في الحالة هذه يا شباب the reversible performance, the reversible cycle performance, even though for these two separate cycles, both will have the same theoretical efficiency. So all reversible cycles operating between the same thermal reservoirs have the same thermal efficiency. Okay? So again, all reversible cycles operating between the same thermal reservoirs have the same thermal efficiency. فبالتالي يا شباب الماكسيمم performance هنا بيعتمد على ايش؟ بيعتمد على السايكل. طبعا نتكلم عن الريفرسبل سايكل. الافشنسي فور الريفرسبل سايكل بيعتمد على السايكل itself ولا بيعتمد على الثيرمال ريزرفوارز؟ راح يعتمد فقط على thermal reservoirs. Okay, so even though I have two separate reversible cycles, two separate objectives, but if they are working in between or in contact with the same thermal reservoirs, they both will have the same thermal efficiency. واضح يا شباب؟ أي سؤال هنا؟ Any question? طيب let us see here. طيب ممتاز. طيب الحين this is for, we talked about this is now for the power cycle. For the other type of cycles, which is the refrigeration cycle, okay, so now for refrigeration, let's write it here. Refrigeration and heat pump cycles. Okay. So if you remember, for a refrigeration or heat pump cycle, the way the cycle works is very similar for both. So I have hot reservoir, I have cold reservoir, okay, and I'm using power input. So I have work of the cycle as input in order to, so if it is a refrigeration cycle, my objective is to cool this cold side. So my objective is to have as minimum Q cold as possible. For the heat pump cycle, the objective is to have as maximum Q hot here as possible by using power input for heating certain body. Okay, so the coefficient of performance, we call it coefficient of performance for the refrigeration. I call it beta, which equals, what is my desired output يا شباب? Huh? What is the desired output for the refrigeration?
Cold. Yes.
Exactly. What is the input?
Work.
The work of the cycle. So I can rewrite it as, and I know the work of the cycle equals the heat of the cycle, which is the same as the net here, Q hot minus Q cold. So this is Q cold divided by Q hot minus Q cold. For the heat pump, I call it gamma. The objective for the heat pump is to heat your output. Desired output is actually the hot side. Okay, you want to heat something, and over the input, which is the work of the cycle, which becomes Q hot over Q hot minus Q cold, the same as the previous. Alright, فنلاحظ يا شباب the coefficient of performance here, again, it depends on the output and depends on the input. So this is the performance, or the coefficient of performance, for the refrigeration cycle and for the heat pump cycle. Okay. طيب, similar to the thermal efficiency, we have also conclusions for the coefficient of performance for refrigeration and for heat pump. Okay. All right. So again, the coefficient of performance is going to be very similar. The coefficient of performance for irreversible refrigeration or heat pump is always less than the coefficient of performance for a reversible refrigeration. Okay, the same thing, all reversible refrigeration cycle or heat pump cycle operating between the same two thermal reservoirs have the same coefficient of performance. Okay, and the other conclusion is that if you notice, the coefficient of performance is always a finite number, يعني في رقم في قيمة. Okay, usually this term, the numerator, is higher than the denominator, so this is always gonna be more than 1. Okay, and it is a finite number. لكن for a reversible cycle, this number is higher than the irreversible cycle. تمام يا شباب؟ واضح؟ أي سؤال هنا؟ Any questions?
Doctor?
Yes.
We said that W cycle would be 0 for reversible processes, didn't we?
لا, احنا قلنا for single reservoir. انتبه. احنا كنا نتكلم عن كلمة blank statement. هذه خليني اوضحها هنا. This is single reservoir. في فرق.
Okay, now it's clear.
Yes. Good point. طيب الحين السؤال الحين يا شباب، الحين احنا تكلمنا عن البرفورمانس حق الباور سايكل، refrigeration and heat pump cycle. طيب وش الماكسيمم theoretical؟ تمام، what is the maximum theoretical؟ العلماء جايوا يعني لما سووا ابحاث وكذا وجدوا انه for a Kelvin scale، يعني they looked at the Kelvin temperature scale، Kelvin temperature scale. اوكي، يعني جايوا عند الثيرمال ريزرفوارز، تمام، وشافوا التمبريتشر مثلا ان كلفن، فعندي هنا هذه مثلا تي هوت، هذه هنا تي كولد. نفس الشيء هنا عندي انا تي هوت تي كولد. يعني الثيرمال ريزرفوارز هذه يا شباب لها تمبريتشر، صح؟ الثيرمال ريزرفوارز هذه لها تمبريتشر. وجدوا انه when they tried to do when they used Kelvin scale and they found that the ratio of Q cold over Q hot when there is no internal reversibilities, and for a reversible process or for a reversible cycle، وجدوا يا شباب انه الريشيو هذا equals to the temperature ratio in the Kelvin scale. فهمت معنا يا شباب؟ يعني وجدوا ان الريشيو حق ال Q cold over Q hot for a reversible cycle or a process where there is no internal irreversibilities، وجدوا انه equals to the ratio of the temperature of these two thermal reservoirs، the cold to the hot. اوكي، فمعناته لما نرجع للقوانين حقتنا هنا when we go back to our equations، وش الماكسيمم theoretical هنا بيكون؟ ها، وش الماكسيمم theoretical راح يكون for a reversible cycle الحالة هذه؟ instead of Q cold over Q hot I will use what? I will use
T cold over T hot.
exactly, I will use the temperatures for the reservoirs. اوكي، فلو اعطيتك سؤال يا شباب واعطيتك الهيت ترانسفير، اوكي، الكيو هات والكيو كولد، واعطيتك التمبريتشرز تي هات and T cold، can you find the actual performance and the theoretical performance؟ ها؟
Yes.
Yes. كيف؟ الثيوريتيكال بيكون using 1 minus T cold over T hot. الاكشوال performance بيكون ايش؟ 1 minus الاكشوال heat transfer اللي Q cold over Q hot. ولو كان the Q cold over Q hot same as T cold over T hot, this is the theoretical. لكن usually the Q cold and Q hot ratio is different from the T hot over T cold ratio. ليش؟ because this is actual performance, actual cycle. لكن to know the maximum theoretical performance you will use the temperatures instead of the heat or Q. Okay, فبالتالي based on this I can rewrite for a power cycle the performance is 1 minus T cold over T hot. So this is for power cycle. For a coefficient of performance for a refrigeration, so we have Q cold over Q hot minus Q cold. I can divide by Q hot here, divide by Q hot here, divide by Q hat here, and then use T cold over T hot, 1 minus T cold over T hot, then multiply by T hot again here, and then you end up with the same thing but with temperature. Okay, math is amazing. So you have T cold over T hot minus T cold. This is for refrigeration cycle, and for the also gamma here is T hot over T hot minus cold. This is for heat pump cycle. So these are what? These are the maximum. So this is maximum theoretical performance. Any questions here يا شباب? Any questions? Any questions? هذا غالبا يا شباب اللي هو I think this is the only calculation we have in this chapter يعني. If I'm not mistaken. These are the only calculations we have. Okay. So there is one more topic, inshallah, we'll talk about it next class, اللي هو Clausius inequality, which is the basis for the entropy, the new chapter. So inshallah, next class we should finalize this chapter. Okay. We'll talk about one important cycle, ya shabab. It's called Carnot cycle. So we have Carnot power cycle, Carnot refrigeration cycle. We'll talk about that, which is an example of the reversible cycle. And then we'll talk about the Clausius inequality, and that's it. Yani, inshallah, we try to finish the chapter next class. Any questions? Any questions? Everything clear?
Yes, thank you.
طيب شباب. Good luck إن شاء الله.
يعطيك العافية.
يعطيك العافية دكتور.